What if you could perfectly copy a person's jaw movement? I mean, every tiny little detail, and put it inside a computer. It sounds like something straight out of science fiction, right? Well, it's not. It's a real technology that is completely changing dentistry as we speak. We're going to dive into this incredible idea called the virtual kinematic access.
So, here's where we're headed. We're going to start by looking at this classic, century-old dental challenge. Then, we'll get into the revolutionary new idea, the virtual kinematic access. We'll unpack its secret, see how it actually works in a clinic, and then we'll look to the future. A future where AI helps design your teeth.
All right, let's jump into part 1, a century-old dental challenge. For more than 100 years, the field of dentistry has been stuck on this one fundamental problem. How do we actually replicate a patient's unique bite outside of their own mouth?
And here's why it's so hard. Your jaw doesn't just swing open and shut like a door hinge. Oh no, it slides forward. It grinds sideways. It even has this subtle twisting motion. It's this incredibly complicated 3D dance, and it's completely different for every person on the planet. For decades, the best answer anyone had was this thing, the mechanical articulator. And you got to admit, it's a beautiful piece of engineering. Super intricate, very expensive, all metal, but it also required a ton of time and a really, really skilled technician to even get it close. But here's the catch, the big limitation. For all its complexity, a mechanical articulator could only ever approximate the real movement. See, it was fundamentally an indirect guess. It was never, ever a perfect one-to-one copy of what was actually happening in the patient's mouth.
And that limitation, that fundamental problem of just guessing, is what led to a totally new way of thinking. So in part 2, we're going to look at this revolutionary new idea, the virtual kinematic access. This isn't just an upgrade, it's a total shift in philosophy. So let's start with the big question right up front. What if trying to make a perfect one-to-one copy of reality isn't actually the smartest way to understand it? What if a simpler, more elegant model, a smarter map, could actually get you a better result than a perfect recreation of the territory itself? Okay, to really get our heads around this, we just need 2 simple ideas from philosophy. And don't worry, it's super easy. First, you've got ontology. That's just the territory, reality as it actually is, the thing itself. And then you have epistemology. That's the map. It's our understanding, our model of that reality. So the territory and the map. That's it.
So where does this big idea actually show up in the real world? Well, believe it or not, it completely revolutionized the field of dentistry. Yeah, I know, but stick with me. Let's start by looking at how they used to do things, the old way.
For years, the ultimate goal in advanced dentistry was this incredibly ambitious quest to perfectly, physically replicate the exact unique movement of a patient's jaw. The idea was to copy the territory, the ontology, with absolute, perfect precision. A monumental task.
And how did they even try to do this? Well, just look at the tools they used. These things called articulators and pantographs. We're talking large, incredibly complex, almost steampunk-looking mechanical devices designed to capture every tiny nuance of the jaw. The sheer complexity of the tools tells you everything you need to know about how hard this was.
You see, the core belief behind all of this was that to make an accurate map, you had to first perfectly replicate the entire territory. They thought ontology and epistemology, the territory and the map, were basically the same thing. You couldn't have one without the other. And that assumption is what made everything so unbelievably complicated. But then, something completely new came along. A real game changer. A total paradigm shift that was born from deciding to do something radical, to finally separate the map from the territory. And really, the heart of this new way of thinking is captured right here in this one idea. It is better to separate ontology and epistemology. That was the breakthrough. Instead of chasing a perfect copy of reality, the new thinking was, wait a minute, let's just focus on making a better map. And this simple philosophical shift completely changed the question they were asking. It went from this massive, almost impossible question, how can we perfectly replicate physical reality, to a much smarter, more focused question. Hang on, what information do we actually need to make a crown that just works? And that new question led to a totally new goal. The focus shifted dramatically. Instead of this epic quest to replicate the entire jaw skeleton, the objective became way clearer. Just replicate the functional movement of the teeth. That's it. Turns out that's the only part that really matters.
So how does this brilliant new map, this virtual kinematic axis method, actually work? Let's pop the hood and see the really elegant, simple idea that's powering the whole thing. Okay, it's all based on a beautifully simple geometric principle. Any object in 3D space can be completely defined by just 3 points. Think about it, right? You fix one point, and an object can kind of wobble around it. You fix a second point, and now it can only spin on the axis between those 2 points. But the second you lock in that third point, boom, the object is completely fixed. It can't move at all.
This table just lays it all out. The philosophy shifts from ontology to epistemology, from chasing the territory to perfecting the map. The goal changes from replicating a physical access to replicating a functional movement. And the tools, they go from that complex, heavy machinery to just simple, elegant geometry. That shift in the goal is the biggest deal of all. From trying to be a god and find the true physical reality to the practical mission of just making something that works perfectly.
Okay, we've been deep in the world of dentistry. I get it. But let's zoom out now because the lesson here is huge. Let's talk about why choosing a smarter map over a perfect copy of the territory is such a powerful idea for every single one of us.
So what did we get by giving up on that perfect copy? Well, first, the results actually got more accurate. The whole process became unbelievably simpler and faster. And of course, that meant the costs just plummeted. And the bottom line? Better dental care became accessible to way more people. A huge win.
Okay, so that's the theory. That's the beautiful geometry behind it all. But how does this get used in a real dental clinic, day to day? Let's take a look at the digital workflow and see how we go from a real person to a virtual patient.
Okay, so how do we build this thing? Well, there are 2 main paths, and the first one is pretty wild. It's the purely digital workflow. And the name says it all. This approach completely skips the physical models. Everything is captured directly from the patient and lives inside the computer from start to finish.
The whole process kicks off with some prep work. First, a cool little device called an intraoral scanner zips around the mouth and creates these super precise 3D models of the teeth. Then, using CAD software, a special splint is designed. You can think of it like a custom-fit mouthguard, but with these little markers on it. That splint gets 3D printed and fitted onto the patient's teeth, and just like that, the stage is set for what comes next.
Now for the fun part, capturing the data. They use a device called the digital facebo, which is basically a GPS for your jaw. It figures out exactly where your jaw is in relation to your head. To connect that GPS data to the 3D teeth models, they just do a quick rescan with that special splint in place. And then, this is where the real magic happens. It's literally Hollywood-style motion capture, but for your mouth. A headset with 3D cameras tracks those little markers on the splint as the patient moves their jaw every which way. Left, right, forward, open. All of it.
Okay, we've got all this amazing data. Now it's time to put the puzzle together. The dentist helps the patient find their centric occlusion. That's just a fancy term for your most stable natural bite. This becomes the model's home base. Then, inside the software, the Facebo data snaps the upper jaw model into the right place. And that stable bite data, that locks the lower jaw and perfectly. And voila! You have a complete, dynamic, digital replica of the patient's jaw.
Now, you're probably thinking, wow, that sounds complicated. And you're right, it is. But here's a mind-blowing little tidbit from the source material for this explainer. It suggests that in the near future, AI could automate this entire intricate alignment process with just a single click. Imagine, all that work just done. That's not just faster, it could make this amazing technology available to so many more people.
Okay, so that's the all-digital world. But in an age of screens and data, a lot of experts still swear by a more traditional method. This is the path of skill, and it's all about physical reassurance.
So why go analog? Honestly, this quote just says it all. It's just more reassuring to have a physical model. It really gets to the heart of the craftsman's mindset. It's about the confidence you get from touch, from feeling the object in your hands, a feeling that a screen full of data just can't give you.
And this process is pure, beautiful craftsmanship. It starts by making a super accurate plaster model from a traditional impression. Next, they use a cool tool called a Facebo. You can think of it like a compass for your face to get the upper model positioned perfectly on the articulator. And finally, a little wax record, called a mush bite, is used to lock the lower model in place, creating a perfect match. It's an incredible hands-on assembly.
And this is the huge advantage here. It's all about what the technician can physically feel, the weight of the model in their hands, the texture of the plaster, the ability to trace a tiny curve with their fingertips. You just can't feel a pixel on a screen. This physical feedback gives a sense of confidence that's built on years and years of experience.
So we have Team Digital and Team Physical. It sounds like two opposing camps, right? Well, what if I told you they don't have to be? This is where things get really, really interesting. The two worlds can actually be fused together.
So here's how they build the bridge. You start with the perfectly assembled physical model. Then you stick these tiny little marker balls on it. After that, a 3D scanner captures the entire setup, the articulator, the models, everything. That scan data is then used to create what's called a digital twin, a perfect one-to-one digital copy of all that painstaking physical work. It's the best of both worlds.
And this really lays out the difference perfectly. The fully digital path, it starts with the patient and lives completely inside the computer. The hybrid path, though, starts with that physical plaster model, something a technician can actually touch. Both ways work great. It just gives clinics the option to choose the workflow that they're most comfortable with.
So we've got the data, we've built the model, we're done, right? Well, not so fast. Here's the twist. No matter how carefully you record it, raw motion data always has these tiny little errors and glitches in it. It's just noise. And that noise can make the digital model move weirdly or cause the virtual teeth to crash into each other instead of fitting together smoothly. So the raw data isn't good enough. It needs to be perfected.
And that's where AI steps in to be the hero. The solution is AI optimization. Think of it as the ultimate finishing touch, the final polish that takes both methods to a whole new level of perfection.
So what's the AI actually doing? Well, it looks at the entire path of your jaw's movement and hunts down those micro errors that no human could ever spot. Then, it intelligently smooths out all that raw, jittery data, transforming it into a motion that is perfectly fluid and completely natural. It really is like adding a final, almost divine touch of technological perfection.
And what's so amazing is that the virtual kinematic axis solves a problem that has been a headache in dentistry for decades. See, every single person has a slightly different width between their jaw joints. In the physical world, that meant every piece of equipment had to be manually tweaked and adjusted for every single patient. But this software uses a brilliant mathematical trick called coordinate transformation to basically make that problem disappear. It takes any patient's data, no matter their anatomy, and converts it to fit one universal, standard virtual model.
And this leads us to the very core of this whole innovation. And believe it or not, it all comes down to a single number. One number that standardizes everything and makes this all possible.
And that number is 110 millimeters. It doesn't look like much, I know, but in this world, that number is absolutely profound.
Here's why it's a total game changer. By standardizing the width of the virtual articulator to 110 millimeters, the software can just elegantly ignore the patient's specific anatomy. That coordinate transformation we talked about handles it all. This means the dentist doesn't have to worry about the width of the jaw anymore. They can focus purely on what really matters, the actual motion of the teeth. It creates this one-size-fits-all platform that's consistent, universal, and error-free.
And you can even take this digital twin to the next level. For really complex situations, you can overlay the patient's CT or MRI scans right onto the model. When you do that, you get a complete digital replica, not just of the teeth, but of the underlying bones and joints that are actually driving all that movement. It's the whole picture.
And the real-world advantages here are huge. This method captures super complex movements that those old mechanical devices couldn't even dream of. Plus, dentists no longer have to waste time searching for some theoretical center of the jaw joint. They can just focus on the one thing that actually matters, the cold, hard data of how the patient's teeth really, truly move.
Now, this is where this technology really shines. It's for these cases called long-centric and wide-centric. So what does that mean? Well, for many of us, our bite isn't just one single perfect point. It's more of a small area, a little zone where our teeth can comfortably settle and slide around. A good way to think about it is like a gear shift in a car. There's a little bit of play or wiggle room in neutral, right? Well, for decades, those old mechanical articulators just couldn't deal with that. They'd force the bite into one single fake point, and that's why you'd get a new crown and it would feel high, and the dentist would have to sit there and grind it down. It was a nightmare. But now with the virtual kinematic axis, we can map that entire area of movement, that whole wiggle room with absolute precision. We're finally designing for the patient's actual bite, not some made-up ideal point.
Now, as cool as all that is, the most exciting part is what this unlocks for the future. And that brings us to our final section. AI designs your teeth. This is about more than just copying what's there. It's about laying the foundation for artificial intelligence to design what should be there. Welcome to Gnathology 2.0.
I mean, think about it. AI is only as smart as the data you feed it. And what we have here is this incredibly precise, dynamic, personalized data about jaw movement. It's the perfect fuel. It's the 5-star gourmet training data that an AI needs to get really, really smart about teeth.
And this quote just says it all. Nothology 2.0 is not about recreating the past with new technology. It's about enabling AI to create the future. We're not just putting a digital screen on an old idea. We are starting a completely new chapter.
So what does this future actually look like? Well, it means AI becomes a co-designer, a true partner for the dentist. It's an AI that understands your individual movements so perfectly that it can intelligently design the ideal shape for your new teeth. A shape that is perfectly functional, looks beautiful, and is truly 100% personalized just for you.
So let's end with that thought. A future where AI understands every nuance of how your jaw moves, and it designs a tooth that is functionally and aesthetically perfect for you and for you alone. That future, it is a lot closer than you might think. The virtual kinematic access is the key that unlocks that door. So the only real question left is, are you ready for it?
All right, let's talk about how our bodies deal with damage. You might think the goal is always perfection, but the real answer is actually way smarter. And we're going to start with a part of you that's working right now, your jaw. Okay, so let's just dive right in. When something in our life breaks, we want it fixed perfectly, back to its original, flawless state. And we kind of assume our bodies are trying to do the same thing after an injury. But what if that's not the point? What if biology's real genius is in a much more practical, much more clever strategy? So our story really kicks off with the temporomandibular joint. You've probably heard it called the TMJ. It's this super complex hinge that connects your jaw to your skull. And believe me, it does a phenomenal amount of work, day in and day out. Tucked inside that joint, there's a little cushion made of something called fibrocartilage. Think of it like a tiny, powerful shock absorber. But every single time you chew or talk or yawn, that disc is taking a hit. It's literally designed to wear down over time. But don't worry, your body's got a plan. And this is where it gets really cool. Your body is constantly, and I mean constantly, patching up this cartilage. But here's the twist. It isn't trying to make it perfect again. It's not going for a factory reset. Nope. The goal is something way, way smarter. And that brings us to the big idea for today, optimization. See, your body's number one priority isn't to perfectly restore how things used to be. It's all about making sure things will work in the future. It's just about keeping the whole system up and running. To put it simply, optimization just means getting the best possible result with what you've got to work with. I mean, think about it. Your body has a limited energy budget, a limited supply of raw materials, and it's always short on time. So the goal isn't to build some museum-quality jaw joint. It's to keep you chewing and talking without missing a beat. This analogy is just perfect. Imagine your body is a road crew on the super busy highway. A pothole shows up. What do? Do they shut down all the lanes for weeks to find the absolute perfect shade of asphalt? Of course not. They get out there, they patch the hole as fast as they can, and they keep the traffic moving, because function always comes first. And this is exactly how that biological road crew works. It's all about speed and efficiency, not perfection. First, your immune cells rush in and they clear out all the debris, the damaged tissue. Then, new collagen gets laid down like a quick patch. And finally, the body actually remodels that patch to make it better at handling stress. It's a fast, good enough strategy to keep your jaw working so you can get on with your life. Okay, now let's zoom out for a second. Because this brilliant, good enough strategy, it isn't just for fixing your jaw. It's a fundamental principle for how all of life gets built and, more importantly, how it adapts to a world that's messy and totally unpredictable. We tend to think of our DNA as this rigid, static blueprint with exact measurements. But that's not really how it works. It's much more like a dynamic network of feedback loops. Your genes have information about when to build things and where to build them. And this process shapes an organism as it grows and responds to what's happening around it. Life is never perfect, right? There's always what scientists call environmental noise. Little shifts in temperature, changes in what you're eating, or just random mistakes cells make. All of this can disrupt the plan. So how does this dynamic blueprint deal with the unexpected? Well, it turns out living things have two incredibly powerful and kind of complementary systems for making sure things stay on track. There's one for dealing with the minor bumps in the road, and another for when the entire road changes direction. The first system is called canalization, or you can just think of it as robustness. It's this amazing self-correcting mechanism. So, for example, even if there are small variations in the number of cells when a fruit fly is developing, its leg will almost always end up with the right number of segments, 5. The developmental path is just so deeply carved out that it filters out all that minor noise. But what if the change isn't minor? What if it's huge? Well, that's where the second system comes in, phenotypic plasticity. This is all about flexibility. For instance, there's a species of tropical goby fish that can actually grow different-sized fins depending on whether it grows up in fast-moving water or slow-moving water. This isn't an error. It's the fish choosing the best pre-planned body design for its specific environment. It's incredible. So here you have it, side by side, life's two brilliant strategies. On one hand, you have robustness, which makes sure you get a consistent result even when there are small errors. On the other, you have flexibility, which allows for adaptation when the whole world changes. It's basically the ultimate survival toolkit. All right, so we've talked about optimization, and we've talked about this dynamic blueprint. Now it is time to bring it all together. Let's see how these two incredible concepts play out in the one place we started this whole journey, the human jaw. So dentists have this term centric relation, and what it refers to is the theoretical ideal position of the jaw. That single, perfect spot defined by our genetic blueprint right at birth. It's our starting point. But what's so amazing is that over a lifetime, this one single point transforms into something way more complex and, frankly, way more interesting. This timeline really shows the incredible journey. We start at birth with that one single ideal position from the blueprint. But then, well, life happens. In childhood, our jaw shifts and adapts to growth and new teeth. As adults, it enters this state of constant optimization, always adjusting to wear, to stress, even to dental work. And by old age, that single starting point has evolved into a totally unique, personal map of functional positions. It's the history of our life, written right into our own body. This is the journey from a static blueprint to dynamic optimization. So the big takeaway here is this. The so-called ideal position of your jaw isn't some fixed destination you're supposed to maintain. That initial blueprint, it's just the starting line. The rest of your life is this amazing journey of continuous, practical optimization. Which brings us to a really fascinating final thought. If our bodies are fundamentally designed not for perfection, but for good enough, constantly adapting and optimizing throughout our entire lives, what does that say about our idea of ideal health? Maybe health isn't some static state to be achieved. Maybe it's a dynamic process of adaptation. It's definitely something to think about. Thanks so much for joining me for this explainer.